So this first lesson we're going to look at is the Hadley cells. Now, for me, understanding this process leads us into so many areas of MET and makes it much easier to understand those different aspects as we move forward. So here we've got the Earth and the Sun warming it up. Now we know the Earth's actually tilted towards the Sun, about 23.5 degrees. We're going to ignore that and think of it as a normal axis because that tilt's effectively giving us our seasons. We also know what's happening in the southern hemisphere also happens in the northern hemisphere. So we're just going to concentrate on our northern hemisphere. So here we have the Sun and its rays hitting the Earth. And as we can see, the rays have less distance to travel to the equator than they do to the pole. So we know the equator is warming up much quicker. We also know if we heat air, it becomes less dense and it starts to rise. So because our air is here, it becomes less dense, we're going to have an area of low pressure here at the equator. So we're heating our air up and it starts to rise. Now eventually it's going to reach the tropopause and can't go any further. So some is going to move down south to the southern hemisphere to store those cells, but our air is going to start moving north. Now, as it starts to move north, it gets away from that equator and it starts to cool down. So as the air starts to cool, it's eventually going to become less dense than the surrounding air. And that's going to be about 30 degrees north and it's going to start to sink. As it sinks and it eventually reaches the surface, it can't go any further. And we know air is going to flow from high to low. So we're going to have an area of high pressure here and that air is going to flow back to the equator. Some air is also going to continue flowing north, which we will look at near the end. So you can see we've created our first cell, and that is the Hadley cell. The next cell we're going to look at is up at the North Pole. So we know our air is far more cooler and colder, therefore it's going to be more dense. So it's going to be sinking at that North Pole towards the surface. As it hits the surface, it can't go any further, so it's going to start flowing south. As it starts to flow south, it's going to start to warm up, and it's eventually going to be warmer than the surrounding air, less dense, and it's going to start to rise, and that happens at about 60 degrees north. As it rises towards tropopause, it's not going to be able to go any further, and so it's going to start flowing back up towards that pole, where we know we've got an area of low pressure here. Some air is going to continue south into that third cell. But that second cell there, you can see, is our polar cell. So finally, our final cell here in the middle is effectively like a cog working between the other two cells. So we start here. We know we've had that descending air from the Hadley cell, and we said some's going to flow north, because we know this is an area of high pressure, and this area is low pressure. So we can see again, it's flowing from high to low towards 60 north, high to low to the equator. Now, as it flows towards that 60 north, even though it's cooling down, it's going to be forced up with that other air at the polar cell. And as it reaches the top of the polar cell here, it's going to flow us back down south, as well as some of that air flowing north. As it reaches the descending air of the Hadley cell, that's going to force it to descend. And that's given us our final cell, which is that ferro cell, or our cog. So from here, we can see we started off with this area low pressure as the sun's rays warmed that air, made them less dense and started to rise. This is where we get our high pressure at the tropopause. We know air is going to flow from high to low. So we've got an area of low pressure here at 30 north, high pressure at the surface. Low pressure here at 60 north, high pressure at the tropopause, low pressure at the pole tropopause, high pressure at the surface. So we can see throughout our areas are flowing from high to low, high to low, high to low, and high to low. So the final thing we're going to look at for this phase is the variation in the tropopause heights. So as I said, we know our air is warming up here at the equator far quicker, and due to thermal expansion, we're going to have a tropopause that's higher. So we can see our tropopause height at the equator is about 52,500 feet and minus 75 degrees, really high and cold. Because our air at the North Pole is far more colder and more dense, it's going to be lower. So we've got 26,000 foot and minus 45 degrees. And then if you look at our standard atmosphere, we all know 36,090 foot and minus 56 degrees mid-latitude. And those are our variations. The next section we're going to look at is going to be the Coriolis of force and how that also links into this area.